All right, welcome back. Before we do our next example, let's just go ahead and talk about the rational zeros theorem, just the full version. Okay, so the full version of the rational zeros theorem states that if you're given a polynomial, okay, f of x equals a sub n, x to the n, all the way down to a1x plus a sub 0, then the possible rational zeros are the factors of a sub 0 divided by the factors of a sub n. Okay, so let's do just a little example. Okay, so before we get into the full factoring, let's just do an example. Let's take, for example, 5x squared minus x minus 18. Okay, so we're going to take the factors of 18 divided by the factors of 5. Okay, so let me give myself a little more space. Factors of 18 are plus or minus 1, plus or minus 2, plus or minus 3. Definitely did not give myself enough space. Plus or minus 6, plus or minus 9, plus or minus 18. And the factors of 5 are plus or minus 1, plus or minus 5. Okay, so our possible rational zeros are this huge list, plus or minus 1, just writing them all out. And then also over 5. Oops. Okay, so you see what I did there, right? I just took all the numbers in this list and divided them by the numbers in this list. So this was the ones divided by 1, which has to always be there, and then divided by 5, which is there in this case. Now, this one's nice because we can actually factor this, okay? Remember, when you take this, you're going to take and look for two numbers that multiply to 5 times 18 is 90, and subtract to negative 1. So I'm going to rewrite this as 5x squared minus 10x plus 9x minus 18. And then I'm going to do a little factor by grouping. This is not really part of this. It's just a reminder of this. So 5x times x minus 2 plus 9x minus 2. And that equals 5x plus 9 times x minus 2. So what are our roots here? X equals 2, x equals negative 9/5. 2 was in our list, 9/5 was in our list, okay? So I just wanted you to see that played out. All right, let's do an example. Let's factor f of x equals 5x cubed minus 39x squared plus 27x plus 7. Okay, so what are our possible rational roots? Okay, factors of 7 over factors of 5. All right, plus or minus 1, plus or minus 7, plus or minus 1, plus or minus 5. So we're going to get plus or minus 1, plus or minus 7, plus or minus 1/5, plus or minus 7/5. Okay. All right, let's check. Let's check 1 and let's pray that it works. Okay. So 5 minus 39 is negative 34. Plus 27 is negative 7. Plus 7 is 0. So 1 is actually a factor here. Oh, I like that. So 1, 5, negative 39, plus 27, plus 7. 5 comes down. Okay. 5 times 1 is 5. Negative 34. Negative 34 comes down. Negative 7. Then 1 times negative 7, 0. Okay. So we get our original 5x cubed minus 39x squared plus 27x plus 7 equals x minus 1 times 5x squared minus 34x minus 7. We can still factor this. Okay, this is still factorable. Now, my rule is if I can factor it, I'm going to factor it. If not, when I see a quadratic, I'm going to use the quadratic equation. I can see where this factors because I know 5 times 7 is 35. 35 minus 1 is 34. So I'm going to write this as x minus 1. And I'm going to do the same thing I did before in that example. 5x squared minus 35x plus x minus 7. Doing factoring by grouping. 5x comes out. X minus 7 plus, oh look, x minus 7. Remember, even though it's not written, there's a 1 implied there. Okay. So we get x minus 1, 5x plus 1 times x minus 7. So what are our roots? X equals 1, x equals negative 1/5, or x equals 7. I want us to just notice the negative 1/5 was in our list, and the 7 was in our list. And of course, 1 was in our list. All right? All right. That's it for this section. All right. See you guys in the next videos. Getting close. I'll see you all soon on Monday. Looking forward to it.